Okay. So, what you need to do, you need to open up Management Studio and you need to connect to Multidimensional Analysis Services instance. Okay. After you have connected to Multidimensional Analysis Services instance, you need to go to File, you need to go to Open, and then here you need to go to File again. Then you need to select the location wherever you have kept those MDX scripts, whichever location on your computer. Then we'll first discuss the queries in the MDX query 1 file. So highlight that file, MDX query 1, and then click open.
Indra, could you please go over it again?
Okay. Now, when you open this window, at the top, you see the databases which are there on your server. So we will run this database against the Microsoft
Hello, Ashik.
because that is a complete solution. So you need to select this AdventureWorks DW 2012 Multidimensional E, the Microsoft solution,
Excuse me, Indra.
as your database. And here in your cube,
Hello?
why is it showing mind customers only? One second. Maybe mine is not processed properly. Let me process this again.
Indra, could you please repeat the steps? Somehow I'm not able to open the file.
Yes, what you need to do is you need to go to you need to go to connect to Analysis Services and Management Studio, and then you need to go to File, Open, and then you go to File again and select the MDX script. This is the MDX script. Select the MDX script file and open it. So here you need to select the database against which you want to execute your MDX queries. So I will be executing against the sample database from Microsoft, and here you select the cubes and the perspectives against which you would run the query. So I'm selecting the AdventureWorks cube here. Okay, these are all the measure groups, and I will run my queries from here. Okay, so before I start the MDX sessions, I will just give a brief overview as to how MDX is used. Uh, in SSAS, in multidimensional SSAS, when you're creating calculated measures, when you're creating named sets, when you're creating KPIs, when you're creating reports, SSRS reports from the multidimensional cube, every time you will need MDX, you will need to use MDX. So MDX is one of the, is not one of the, is the, is a very important language that you need to know if you're working with multidimensional SSAs. It is like the T-SQL of relational data warehouse. So if you are working in a relational data warehouse, and if you're creating reports or anything from the relational data warehouse, everywhere you require T-SQL, right? Even if you are working on SSIS, you need T-SQL. You need to use T-SQL. Similarly, if you are working with multidimensional SSAS, you will need to use MDX. So that is, the language of the cube. Now, since, what happened is over the years, most of the people who have been using multidimensional SSAs, because multidimensional SSAs is from a long time. In SQL Server 2000 also it was there. So over the years, what the feedback that Microsoft has got about multidimensional SSAs, that it is a very good OLAP tool. No doubt, multidimensional SSAs is a very good OLAP tool, and if you know how to do development in multidimensional SSAs, it is definitely very beneficial. You can create complex calculations, and it also provides very good performance. But there are certain things which are also there with multidimensional SSAs. The first and foremost thing is the concept, is the use of MDX and the concept of multidimensionality. The, the use of MDX and the concept how the multidimensional database works, that is not very easy to understand, and most people have an are not able to get it clearly how to use MDX and how to use the multidimensional cube. So that is why there is a learning curve associated with it. It is not that easy a tool where you can just in a few days you can master it, and you can work on it. So MDX is a language, but to be honest, it is not a language which you can. It is difficult to learn it in a few days. So over the time, the more when you keep on working with it, you get comfortable with it. So in 1 or 2 days, it is very difficult to learn MDX. Yes, you can start working on MDX, but to become an expert, or to even to become comfortable with MDX, it takes time. It is not that simple, because the concept and the syntax, everything is a bit complex in MDX. Okay, so that is why Microsoft launched the tabular version of SSAS in 2012. Because in the tabular version of SSAS, the calculated measures and everything that you create, that is in DAX, not in MDX, and even you can query the tabular model using DAX. You can also query it using MDX. So both options you have. You can query a tabular SSAS model using DAX as well as MDX. And now Microsoft has made multidimensional SSAS also compatible with DAX. So you can create SSRS reports. You can query a multidimensional cube using DAX now as well. I think it is from a later version of SQL Server 2012. So yeah, I think it is cumulative update 4 or something like that. That Microsoft has made multidimensional SSAS also compatible with DAX. So now you can create your SSRS reports using DAX from multidimensional SSAS. So this is the background, why tabular SSAs and DAX came into the picture. And so I will be taking around, uh, you know, 3 sessions or so on MDX. So I will I'm giving you that, I'm telling you beforehand that it is difficult for you to be like, if you haven't worked on MDX earlier, it is difficult for you to, so within just a couple of days, be able to be an expert on MDX, or to be able to write MDX queries comfortably. So it will take time. So just try to get the basic concepts and the basics, how we can write MDX, and then when you start working on MDX, the more you work, the more comfortable you will get. So you might not initially, you might not be able to write MDX queries, and you might have some issues. You might run into errors and that. So that is fine. That is common. That is a common thing. So it will take a little bit of time for you to grasp it, and to be comfortable with it. So we'll start from the most basic of queries. So here, this is most simple MDX queries. It says select from, and then this is AdventureWorks is the cube name. Okay, select from cube name, nothing else. So if I run this query, you can see that it is returning me a value. Okay, so what value it is returning, because I haven't specified any measured name or anything in my query. So if you do not specify any measure in your MDX query, by default it returns the value of the default measure in the cube. So in the cube, whichever you have set as the default measure, it will return that measure's value. So let us see in the cube which is the default measure. Okay, so if this is my cube, if I right click and go to properties of the cube, there is a default measure and the default measure is reseller sales amount. So that is why when I run this query against this cube, this value that it is returning, it is returning me the reseller sales amount. Okay, now let us be more specific. So here in my select query, I have specified the reseller sales amount on 0. 0 is nothing but an axis. When you write an MDX query, you need to specify the axis. Okay, you can write 0 or columns. Columns is more common, but some people, you can also specify columns with 0. And then you product categories dot let me delete parent now. So product is my dimension, product categories is my hierarchy, and helmets is a member of that hierarchy. So if you go to the product dimension and you go to the product categories hierarchy, here you can see here helmets. So it's a subcategory in the product categories hierarchy. So dimension dot hierarchy name dot member name. On instead of one, you can write rows from AdventureWorks. So this is the most simple select query in MDX. So this will give you the reseller sales amount for helmets. Okay. Now instead of columns, the columns is an axis and rows is another axis. Okay. This is columns. Okay, this is columns. This is rows. Okay, columns is one axis, rows is another axis. Now you can also specify your axis with number. There is a number associated with it. So for columns, you can also specify it with 0. And in case of rows, you can also specify it as 1. So you will get the same result. Okay. So you can also specify your axis with numbers. Okay. Now, let's say I told you that um, yes, correct. Mostly fact tables are columns and dims are rows. Most of the cases. But if you want, you can do it otherwise as well. Like I can put it like this also. If I want, I can put it a 1 and 0. I mean, mostly you will put your measure on your columns and dimension and on your rows. But see, you can do it other way as well. Okay, so now this what I showed you. So when you're working with SSAs, most of the time you have to work with hierarchies. So you should know how MDX works with the hierarchies. Now you can see here. Now there are certain terms I will first explain which you need to be comfortable with, because when you're working with MDX and hierarchies, we will always use these terms. So you should understand it. So this is my product categories hierarchy. Okay. These are my attribute hierarchies. This is a user defined hierarchy. Okay. Product categories hierarchy. In this hierarchy, I have three levels. So understand the term. There is another term called level. So in this hierarchy, I have three levels. Category is one level, subcategory is another level, product is another level. So these are levels of the product categories hierarchy. And when I go under this level, under category, accessories, bikes, clothing, these are members of this level and this hierarchy. So accessories is a member. Another term is member. Accessories is a member of the category level of the product categories hierarchy. Bikes is a member of the category level of the product categories hierarchy. Okay, cleaners is a member of the subcategory level of the product categories hierarchy. Okay, so these terms you need to understand. Also, there is an all member. When you talk about a hierarchy, in a hierarchy at the top, you have the all member, which is actually all of the products or all of the accessories are aggregated to that member. But all is one single member in SSAs. It is not multiple members. It aggregates with all the products are aggregated to the all member, but all is a single member in the hierarchy. Okay, now, so these are terms which you need to be comfortable with. Now, this is my product dimension. This is my product categories hierarchy. Now, instead of dot helmets, if I do not write anything, only product dimension and hierarchy, nothing else. Okay, nothing else, then what will it return me? It will return me the, just check it, when I run this query, sorry. So when I run this query, it will return me the all products. Why? Because when I am, this is also an important concept of MDX. When I do not specify any member in a hierarchy, when if I do not specify any member in a hierarchy, it returns the default member of that hierarchy. And who is the default member of the hierarchy? The all member is the default member of the hierarchy. So if I do not specify any particular member or any level in my MDX query, it will return the all member by default. Okay. Also, I could have hard coded it as all products. So it would return me the same thing, but that is not required because by default it will return me the all member. So if I write it like this, it will return me the same result. Okay. Now this was about the default member. Now let's talk about, let's say I want to, this is the default member. Let's say I want to display all the members of this hierarchy. I mean, starting from all the categories, all the subcategories, all the products. Then what I need to write is I need to write dot members. So this will return me all the members in the product categories hierarchy. So you can see here, so this is returning me all the members, products, categories, subcategories, everything. Now you can see here that for bike stands, the value is null. So sometimes what will happen is when you're running an MDX query in a report, you might want to, usually you might do not want to display the null values where you do not have a value. So how you can filter out the members with null values? Here you can write non-empty. Before that, you can see that when you run an MDX query, how many rows were returned or how many columns were returned, that you will get by going to messages. In messages, it says cell set consists of 440 rows and 2 columns. So it actually returned me 439 records because the first record is actually a header. The first row is the header. So it actually returned me 439 records. Okay. Now let's say I want to filter out these members with null values. So I can write here non-empty. So if I write here non-empty, You can see here the null values are filtered out, and you will see here the number of rows will have reduced to 373. Okay, so now this product categories dot members, it is returning me all the members of the product categories hierarchy. Now let's say I only want to view the members at the category level. So then what I will do is here after the product hierarchy name, I will put the level name. So the level name is category. This dot members. So this will return me only the members of the category level of this hierarchy. So you can see here accessories, bikes, loading components. Okay. So these are the common ways of writing the simple MDX queries. Now, when you talk about these hierarchy functions, members and everything, there is also another thing which you need to understand, which we use a lot in MDX, that is parent and children. So when you navigate a hierarchy, in a hierarchy, now let's say this is my hierarchy. Okay, here this is my accessories, and under accessories I have these subcategories. Okay, so if I say fenders is a subcategory member, so if I say fenders dot parent, I am referring to accessories. If I say locks dot parent, I am referring to accessories. If I say mountain bikes dot parent, I am referring to bikes. If I say accessories dot parent, I am referring to all products. So parent is a function which returns you the immediate member at the immediate higher level. The member who is at the immediate higher level, on top of that member, that is what it returns if you write dot parent. Okay, so it is a member name dot parent. Now there is another, like parent, we also have children. So if I write accessories dot children, it will return me all these members. If I write bikes dot children, it will return me all these three: mountain bikes, road bikes, touring bikes. So children are the members which are just below that particular member in the hierarchy. So let me show you by an example. So if I write fenders dot parent, dot parent. So this will return me accessories. Okay. Now if I write accessories dot children, it will return me all these subcategories. It will return me all these subcategories. Okay. So this is the basic things which we use while writing MDX queries. So, then the next thing that we would be discussing is the where clause. Okay, so in my MDX queries, I can use a where clause. The where clause is nothing but it is a, in MDX, it is a slicer or a filter. So you can think of where clause as a slicer or a filter. So if you look at this query, it is returning me the reseller sales amount for accessories dot children. Okay. Now this is actually returning me for all years. For all years. Okay. Now let's say I want to see it only for fiscal year 2007. So if I want to see it only for fiscal year 2007, I will I have to slice this data. I have to filter this data because this is for all years. So I can add this filter condition in my where clause. So in my where clause, I have put date dot fiscal year 2007. Here, uh, date, you can see here, date is the dimension. Okay. Fiscal is the hierarchy. So if we go under date, you can see here date dot fiscal. Fiscal is the hierarchy. Fiscal year is the level. So this is dimension hierarchy level. And in that level, we have 2007 as one of the members. So I am filtering this data based on fiscal year 2007. So using the where clause. So this will only return me the data for fiscal year 2007. Okay. Now here there is one thing which I would like to mention here is, so where clause, you understood that it filters the data. Now let's say I will give you an example that so this is returning me all the children of accessories, all the subcategories of accessories. Okay. Now, let's say I'll give you a requirement. Let's say I want to filter this data and see only, I want to see only data for cleaners. Okay, so if I write where this product categories is cleaners, it should filter the data and show me the data for cleaners only, because right, because where clause filters the data, so it should work like that. So ideally I should be able to here, this is where the ambiguity of MDX comes into the picture, where if you write where and you go to product categories, so here you have cleaners. So if I put this in my where clause, this should return me only the data for cleaners, right? Because I am filtering that data with only cleaners. Logically, this is how most people think as this should work. But this won't work in MDX. Why? Because you can see this error message. The product categories hierarchy already appears in the axis 1 axis. Why? Because in the where clause, you cannot use the same hierarchy which you are using on rows or on columns. Here in on rows on columns, whichever hierarchy you are using, that same hierarchy you cannot use in the where clause. That is a limitation of MDX. Now, let's say in project scenario, I have come across this situation a lot. Let's say when I'm running trying to write MDX queries for my SSRS reports, and I have to enter multiple filter conditions. So in my report there are multiple filters, maybe 5 6 filters, and I need to filter the data based on those filters, and one of those dimensions are there in my on rows. So it is there in my on rows. So how will I filter that? But I need to filter that using a value. Using a filter, I need to filter that. Like in this case, uh, helmets, I want to filter this data using helmets, but accessories is on my rows. So in this case, the best solution, I will say, from my experience, what I've used a lot, is that if you come across this kind of a scenario in MDX, that you need to filter a value and that value is in your axis, like in on rows. So then how will you filter it? Then the best way is to filter it using subselect. So there is a subselect, the subselect in MDX, it does the same thing as your where clause. It filters your data. So what I can do, I can achieve this result using subselect. So what I'll do is, this is my subcategory. So I will remove this where clause, and in the from I will use a subselect. Select this on columns from AdventureWorks. Okay. So now what we'll do is this will return me only this particular subcategory, and when I'm running this category from using from this, so I will get only that result because it is already getting filtered out in my subselect. So if I run this query, you can see here that I'm only getting cleaners. So this is how, if you face problems with the where clause, because in MDX where clause becomes a little bit of a complex thing if you're using multiple filters. You know, if you're using multiple filters and you're also using it on rows, those dimensions, then it becomes a little bit of a problem. So you can do it. Another option you have is using subselect. Yeah, right. That's right. Now, what is ampersand 29? I will discuss that. I will now discuss that. Just wait for a while. Yes. Okay. So, so this is how you can filter the data using MDX, either using where clause or you can use a subselect instead of where clause. Now, one of the one question was from one of the students, that what is this ampersand 29, which is a very valid question, because you might be wondering, because I took these cleaners, so I just dragged this cleaners, what is this ampersand 29 showing here, because I just dragged it and it is showing ampersand 29. This is my dimension, this is my hierarchy, this is my level, that is fine. But what is this ampersand 29? Now, this you can say how there are two ways by which MDX references a particular member. Okay, MDX references a particular member by two ways. One is by its name value and by its key value. Okay, key value is something, if you remember, while we were developing dimensions, we were specifying key column and name column. Key column, the value of your key column, that becomes your key value, and the name column, the value of your name column becomes your name value. So when I say cleaners, this cleaners, if you look in your dimension, there is for this particular attribute subcategory, there is a key column and a name column. What is the key? The key column is subcategory key and the name column is subcategory name. So 29 is nothing but the key column value, the key value of cleaners. It is the subcategory key value for cleaners. If you query that table where product subcategory key equal to 29, you will see it is cleaners. Now you can also refer this member using its name value. So if I write product dot I can also write this same thing. It is a same member. I can also refer using the name value. So whenever there is an ampersand, it means that you're referring that member using key value. In name value, you do not put ampersand. So if I can also refer this member using name value, then I would write dot cleaners. So the same thing, it is the same thing, only I am referring it by key value and or by name value. So when you drag and drop from here, if you drag and drop any member, it will always pull up its key value. Okay, but I can refer the same member using the name value as well. So you can see here, if I change this, I can change this to its name value. So I can change this to its name value. It will be the same thing. I made some syntax error, I think. Oh, I did not put a bracket. Okay. So you can either refer a member by a key value or a name value, whichever you want. It is the same thing. You can refer it by its key value or its name value. Now, here in this case, there is only one key value. But you remember, while creating dimensions, we created composite key columns sometimes. So for those members, if there are composite key columns, you will see the value of both of those keys. So it will be like something like ampersand 29 and then another ampersand value like that. So I will show you that for months we actually had we had created composite keys. So if I pull up any month, you will see that there are two values because it's a composite key. So let's go to the month here in date. If I go to the month level, these are actually composite keys. So let's say for September 2005, if I drag this member, you can see there are two values here. This is my dimension, this is my hierarchy, this is my level, and then you have two values, each for the key value. So if you remember, for at the month level, we had a composite key which constituted of calendar year and calendar month number. So this is nothing but the calendar year value, which is 2005, and this is the month number of year, which is 9 for September. For August, it will be 8. Uh, for August, this value will be 8. For July, this value will be 7. And for 2006, this will be 2006. For 2007, this will be 2007. Like that. So key value is something which is, it is the underlying code which is displayed, which constitutes that member, and the name value is what is displayed. So I can also write this same member. I can write this I can refer to the same member using its name value as well. This is 7 is July 2007, right? So I can write it like this, July 2007. So it is the same thing. So if I write it as this will also refer to the same member. Okay. So let's take a 5 minutes break and then we'll continue with the MDX sessions. Yes, Sophia, we were on break. Okay, so so we discussed a few things how you can reference um, reference a measure member in a different ways in MDX. Okay. So now the next thing that we would be discussing is using the with member clause. Okay. Now let's say when in your cube, in our cube, like there are a lot of calculated members that we have created, right? Lot of calculated members are here created. They are also created using MDX only. These calculated members are created using MDX only. Now, if you go to your cube and let's say you can use these calculated members for your MDX query. So let's say you can see these are your calculated members and you can use these calculated members for your MDX queries. So, so let's say I'm a report developer and I'm building an SSRS report from a multidimensional cube. So I can use these calculated members in my report query. So for example, let's say let's say I'm using this um reseller ratio to all products. Okay. So what is the sale with, it is a percentage. What is the sale of one product with respect to all products? So this measure is already created in the cube. So I'm a report developer. I can use this in my query on columns and I can ratio to parent product to all products. So I'll take the product hierarchy. So this is my product hierarchy. So here let's say I take um, subcategory all the members. So for each subcategory, what was the sale with respect to was the percentage of sale with respect to all the products. So that will be displayed here. Members on columns from Adventure Works. Okay. Now let me run this query. Oh, sorry. It should be on rows. Okay. So you can see here that this is the percentage of sale of each of these categories with respect to all products. Now this calculation is already there in the cube. If you go to your cube, you can see reseller ratio to all products. This is already there in the cube. So here also, this is also an MDX expression, but this is already there in the cube. So if the calculation is already there in the cube, in your reports you can use it. But let's say, for example, let's take a scenario where this calculation is not there in the cube. So let's say you're creating a report, you want this calculation. It is there in the cube, then you can simply use it. But let's say this calculation is not there in the cube. Then also it is possible for you to do it. There are two ways. One thing is that you can ask the SSAS developer who is building the cube, ask that person to add that calculation in the cube and then deploy and process it, and then you can use it on your reports. There is also another way where if a calculation is not present in the cube, you can write that calculation at the query level. When you're writing the query, you can do that calculation. So how we can do that is using a query scope calculated member. Using with member, I can create a calculation at runtime while executing the query. So I will take this MDX expression, and if I want to write, let's say, imagine that this calculation is not there in the cube, and I want to write that calculation at runtime and execute that query. So in that case, what I will do is, here I have to write this with member. So with member creates a query scope calculated member. The scope of this calculated member is only while running the query. Once the query is completed, that calculated member is gone. It is not saved anywhere. So you can create a calculated member using with member. I'll show you how you can. So let's say you can give any name to this, whatever name you want to give, A, B, C, whatever, with member as, okay, and better you follow the actual, let us follow the actual conventions, measures. So I'm creating a measure. So I can give it, let's say, ratio, so ABC whatever as, and here I will write the MDX expression for this measure. So this is actually reseller sales amount of that particular product, and root of product, which is the root of product actually means the all products. So root of product measure reseller sales amount. This will give me reseller sales amount for all products. So I'm dividing the reseller sales amount of a particular product divided by the reseller sales amount of all products, and I'm displaying it in percentage. So here I will write ABC. So here I have ABC. I am creating this calculated member on the fly, and then I'm using it in my select clause using with member. So this is just in case this calculation is not there in the cube, but you need it in your query. So if I run this, you can see here that it is showing in dollar because I haven't formatted this. So this should be formatted to percentage. Format underscore string equal to percent. I don't remember the format string syntax exactly, but I think this is how it is. Yeah. So now you can see here it is the same thing which was earlier I was pulling it from the cube, and now I have assumed that this calculation is not there in the cube. But even if it is not there in the cube, I can create this calculation using with member. Okay, now there is an important point here. So let's say you need a measure, a calculation in your report. Okay, there are two places where you can write this calculation. Either you can write this calculation in your multidimensional cube and then use it in your report, or else you can use in your SSRS report query, you can write the calculation using with member. So which one you will do? Both options you have. So you can do it either in the multidimensional cube or in your SSRS report query. You can do this calculation using with member. So let me tell you here
I'll do it in the
that
queue.
if you write a calculation using with member at the report level, then uh, this report will not be saved in the formula engine cache, this query. So with member does not save it using in the cache, but in if you go to the report, if you create that measure in the queue, it is that query is saved in the cache. So from the performance point of view, it is always better if you have both options. If you have both the options of creating it in the multidimensional cube or creating it in SSRS report, then you should always create it in the multidimensional cube. Why? There are two reasons. First reason is you will get a better performance from SSAs if you create it in the multidimensional cube. That is the most important thing because performance is critical. So even if you get a 1 second improvement, you should always go for it. So so if you create it in the multidimensional cube, then you will get a better performance. Second is that if you create it in the multidimensional cube, then if your users are using the cube for ad hoc reporting and all that thing, then they can use that measure. If it is not created in the cube, then it cannot be used for ad hoc reporting. If let's say your users are connecting to the cube using Excel and all, so they can only use those measures which are already there created in the cube. If it is not there in the cube, not created in the cube, they cannot use it. So from the usability point of view also it is better, and from the performance point of view it is also better. So always, if you have both options of creating it in the cube or in the report, you should always go for creating it in the cube. But sometimes there are some scenarios. I can remember one experience, one project scenario which I had, where based on whatever parameter the user is passing in a filter, based on that, using that value, I had to do some MDX calculation. So in that case, I had to put that calculation in the report, because I was not able to do that in the from the cube, because based on whatever value the user was selecting, because based on whatever value the user was selecting, let's say March 2010 or say May 2015, user is selecting in the date filter. Based on May 2015, we had to take the last 12 months, and for last 12 months we had to calculate the average. So, so that kind of calculation I was not able to do at runtime on the, because based on the month user selected, I had to select the last 12 months. And those last 12 months had to be put in the rows of the report, in the x-axis of the report. So that was dynamic. So if the user selects May 2015, from May 2015, the last 12 months average. And then if the user, so I had to display all the, so you can dynamically do it using current member, but I had to display the average of the all the 12 months. So it was a straight line. So average of all the 12 months. So it was dynamic, and that kind of calculation was not possible to be done on the cube. So that is why I had to do that calculation at the report level only using with member. But those are some specific type of requirements where you will see that it is not possible to do it in the cube. Then you go with doing that calculation in the report. But 90% or 95% of the times, what I've seen is it is possible to create the calculation at the report at the cube level and then use it in the report. So if that is possible, then always you do it in the cube only. So that is, I would say, 95% of the times that is the scenario. Maybe in some specific rare scenario, it might be that you're not able to write a calculation in the cube. You have to write it at the report level only. So this was about using with member. Okay. Now you similar to with member. Okay, we'll discuss sets, because without set, if I discuss with set, because similar to with member, you can also use with set, set. But you need to understand what a set is. If you don't understand what a set is, then with set you won't be able to follow. So here in MDX, there are two very important concepts, which is very, to be honest, the at the initial level, it is very complex to understand, and this is a very much a multi-dimensional concept. This you will not find this concept in your relational data warehouse. This is a completely multi-dimensional concept. and it is, initially it is a little bit difficult to understand it. So in MDX, there's something called a tuple and a set. Okay, tuple and a set. So when you're writing MDX, many times you will write tuples and sets all the time. Maybe 90% of the times in your MDX expressions, you will use either tuples or either sets. Even in the queries that we have written till now, we haven't used tuples, but we have used set. So you can see here, um, this product categories dot accessories dot children. So these are the children of accessories. This is actually a set. So we have used set in our queries till now. We haven't used a tuple, but I haven't discussed what a set is. So I will discuss it now. So first let us discuss tuple. So for understanding tuple, you have to visualize how the data in the cube is. What is the difference between member and children? Member is like you can see here, accessories is a member, bikes is a member, all of these is a member. Even fenders, helmets, hydration bag, everyone is a member. Okay. Now, if I see dot children, I mean the members who are at the immediate level below it. So if I say accessories dot children, that mean the members which are just below accessories in the hierarchy. So if you look here, so this is accessories. So what these members which are under accessories, these are the children of accessories. These are also members. All are members. Accessories are also members. Hydration packs, helmets, vendors, these are also members. But these members are children of accessories. And accessories is the parent of these members. Okay. Now let us discuss what is a tuple. So in order to understand tuple, you need to understand how the multidimensional cube works. What is the concept between multidimensional cube? So you can see this is an example of how data is stored in a multidimensional cube. Okay, so you can imagine that each axis is a dimension. So here, this x-axis, this is the date dimension, where you have the calendar, year, semester, quarter. Okay, this y-axis, this is the product dimension, where you have the product categories, accessories, mountain, road touring. And this z-axis, this is the country dimension, customer country dimension, where the customer countries are there. Now, here in this cube, there are only 3 dimensions. But just imagine that in a multidimensional cube, you can have n number of dimensions. And you can have n number of axes. So here there are only 3 dimensions. You can have 20 dimensions. You can have 30 dimensions. and this is actually the point of intersection of the dimension values. So let's say if I am looking at the measure for Q1 2003 and for product mountain and for country Australia, then the value would be 893. Why? Because it is the point of intersection of all the dimensions. So a tuple is a single cell in the cube. It is the point of intersection of the dimensions and measures specified in the tuple. So let's say in the tuple I specify this member Q1 CY 2003. I specify accessories as the member from this dimension and then specify Australia as the member for this dimension. So the point of all these three dimensions is this particular cell 1270, and this will be returned as the answer. Now here you have only 3, but it can be 5, it can be 6. So the point of intersection of all of them in the cube, that is the tuple. It's a single cell in the cube. Okay. Now syntactically, a tuple starts with a round bracket. It starts with a round bracket and ends with a round bracket here. So here what I've done is I've created a tuple, a calculated member named A, and in that calculated member I've used a tuple. It starts with a round bracket and ends with a round bracket. And if you see here, see, I have date.calendar year 2007. So for the date dimension, I have 2007. For the geography dimension, I have United States. So geography.United country.United States. For the product dimension, I have category 4. I think category 4 is accessories. And I have reseller sales amount as the measure. In a tuple, your measured is also considered a dimension. So measured is also a dimension. So this tuple will return me the point of intersection of calendar year 2007, country United States, product category accessories, and reseller sales amount. So the point of intersection of all of them will return me one value in the multidimensional cube, and that value is my tuple value. Okay, so if I run this query, you can see this is the value. So this is the point of reseller sales amount for calendar year 2007 for United States and for the product category accessories. Okay, now there are certain things which needs to be understood here. A tuple is a point of intersection of the different dimension members. Okay, now here if I add if I add 2008, so it should return me the reseller sales amount of United States of product category accessories for the year 2007 and 2008. Previously it was only 2007. So I added 2008 here. Will it work? Will it work? Conceptually, if you think about it, in the cube structure, for here you have 2007, here you have 2008. Tuple is the point of intersection of your dimension members. So will this and this, will they intersect at any point in the cube? Calendar year 2007 and calendar year 2008 will never intersect in the cube. So if in a tuple, you cannot have two members from the same dimension. That is not allowed in a tuple. So if I run this query, you can see an error. The calendar hierarchy appears more than once in the tuple. In a tuple, you cannot have more than two members of the same dimension. Conceptually it is not possible, because as I said, it is the point of intersection of the different dimension members. So if you have two members from the same dimension, how will it intersect? So this is where, the concept comes into the picture of MDX. This is where the complexity comes into the picture, because these concepts you need to understand. How the tuple works and all that. Now, the next thing that I would be discussing is, I've discussed tuple. Another important concept is set. So in an MDX, when you're writing MDX, you will always be using tuples and sets. These are two things which are most commonly used. So that is why you need to understand these two things. A set, tuple is, as I explained, it is the point of intersection of different dimensions, whereas a set is different. Tuple, you can imagine it is one single cell in the cube, whereas a set is a group of cells in the cube. So in a set constitutes of multiple members in the cube. So for a tuple, you will have one single value. For a tuple, you will have one single value. In a set, you will have multiple values. So it is a group of members. A set is nothing but a group of members. And you can have, like in a tuple, as I said, you can have only one member from one dimension. In a set, you can have multiple members from any dimension. Let's say you are in a set constitutes of 10 members. Out of those 10 members, 3 can be from one dimension, 2 can be from another dimension, rest can be from another dimension. Or the 10 members can be from the same dimension only. So a set is a group of members in the cube. So for example, if this that we just now ran this query, here product dot products subcategory dot members. So all these subcategory members, these are actually forming a set. This is actually a set. So most of the queries that we have run till now on rows, we have put a set, multiple members from the same cube. So you can see here, so similar to with member, I can also use with set. So what I've done here is I've created two members. I'm showing you how we can use tuples and sets together. So I've created two members, member A and member B, and each of these member is a tuple. Okay, member A is a tuple, member B is another tuple. Here in member A, the measure is reseller sales amount. In member B, it is reseller total product cost. Then I've created a set. A set is, just remember, a set is enclosed in curly braces. A tuple is enclosed in round braces. Set is enclosed in curly braces. So I've put the product categories dot category. This is the each of the four categories like accessories, bikes, clothing, components. These four. So these four are there. 4, 1, 2, 3, 2. So I've created a set with the name XYZ, and this set constitutes of these four members: accessories, bikes, clothing, and components. Okay, now I am putting these two members which I have created, these two calculated members which I have created, I am putting this on 0 and I am putting this set on 1. Okay, and I'm running this query. So in this query, I'm using both tuple and set. So you can see here, I have created this accessories, bikes, clothing, components. This is a set. Okay, A is a tuple, B is a tuple, and then I'm again using A and B together to form a set. So A and B together I want to display in my query. So A is A is a value from a tuple. B is another value from which is getting evaluated. A is getting evaluated from a tuple. B is getting evaluated from another tuple. Now I want to show them together in my select query. So I am forming a set out of those two tuples. So I'm forming a set out of those two, and then I'm forming another set XYZ. XYZ consists of these four categories: accessories, bikes, clothing, and components. So here in this query, I am using both tuples and sets. So that is the concept of tuple and set. Okay, so any question you have
Indra, I
till
have a
now
question.
regarding what we have discussed? I know
Yes,
that MDX is initially it will be heavy for you because this is not that simple a language. So it will be a little bit difficult, but as of now, you don't try to understand, grasp everything. At least try to get the basics, how it works. And then if you get opportunity to work in MDX, then you can, start developing your skills. But like initially you will not, like in just by taking 1 or 2 or 3 days training, it is difficult to be able to write MDX queries and all. It is not that simple because it's a complex language. So any question you have till now?
I have question, Indra.
All right. So in that case, I will end
Hello.
today's session and I will upload the video in OneDrive.
Yeah.
Hello.
Hello, Indra.
Indra, can you hear us? Hello.
I think he can't hear us. Okay.
You can hear